So here's the drill for today. We'll make sure everybody's cool on the assignment. There won't be any of this KB stuff on the quiz. Okay?
Stuff I know how to do.
But it forms the basis of some of the things that are going to be on the quiz, so that's why I want to go over. So we'll go over this, we'll take the quiz, then we'll go into lab. I'll explain what's going to happen there. No, you don't have any homework tonight. Okay?
Oh,
Okay?
he loves to just stress. On the nights I can have homework.
What do you mean?
No, we have Nickerson. You can't have homework.
Nickerson, when do we have, today?
Yes.
I'm not going to Nickerson. Why not
Okay.
basketball practice?
Stuart looks so betrayed. looks so betrayed.
Yeah, he doesn't score points anyway, we're fine.
Yes, I do, bro.
You gonna take that, Charles?
Okay.
Basketball question.
Basketball question.
Charles, you ring it.
If you have any type of acid, okay, just a generic, and you can use this on the quiz, you can just write HA. So, in a situation where it's an acid, technically there's a water molecule,
Sure.
and you're gonna form OH3O plus, and you're gonna have an anion left over. So the question is, what's the dominant form? Does equilibrium lie on the right? In other words, do you make a lot of hydronium ions and anions, or does it say mostly on the left? Okay, that's the $1,000,000 question, and those are the two extremes. So if it's a strong acid, that hydrogen atom basically has no attraction towards the anion, and equilibrium lies over here. So if it's a strong acid, that's 0.1 molar, that's 0, basically all of that goes away. This becomes 0.1, okay, and you're off to the races, okay? That's, by definition, that's what makes it a strong acid. What we're gonna be dealing with are weak acids. So on weak acids, you don't know how much ionizes, so you go, oh, that's gonna be minus X, plus X, plus X. That becomes X, that becomes X, that becomes 0.1. So then you go, oh, Ka equals that hydronium ion concentration times that anion concentration divided by whatever the concentration of the acid is. Okay? There you go. So you're going to have a problem like this. I'm going to give you the Ka value. You understand when you find X, you're finding the hydronium ion concentration. You take the negative log of that. Boom, there's your pH. Okay? And the more that ionizes, the higher the concentration of your anions are going to be. That means you're going to have a bigger Ka value. If these don't ionize very much, you're going to have a very small Ka value. It's cool. Now, in a situation where you have a base, okay, so if you look like on problem 79, or let's do 80, because that's problems is not in the back. The answers aren't in the back of the book. So if you look at it out of 80 from yesterday's assignment, so you're going to have a 0.15 molar solution of sodium fluoride. So this is what I showed you all yesterday to make the nice magenta colored solution, which is still not water. So, first off is sodium fluoride. So, all group 1 elements, and sodium is the poster child for this, are soluble in water. So, you put this in water, you have the fluoride ion. This is not going to be on the quiz, but it's an important part. So, the fluoride ion is going to react with water, and you're going to form hydroxides. Okay? So, in this situation, you have a 0.15 molar solution of the solution, 0.105. It's the same process. This starts off at 0, that starts off at 0. Minus X plus X plus X. So this becomes 0.105, this becomes X, this becomes X. Now, this is where this becomes problematic. You need the Kb value for the fluoride ion. You cannot find that in the back of the book. There is not a listing for the fluoride ion Kb value. But what is there? The Ka of hydrofluoric acid, okay? So you can look up the Ka value of hydrofluoric acid. Then you know that the Ka times the Kb gets you the autoionization constant of water, 1 times 10 to the negative 14. So this just involves a couple more steps. It's the same concept, okay? So you divide by your Ka value, so that's going to get you some number, which is your Kb value. That's still going to equal your hydronium fluoride, which is X, times your hydroxide ion concentration, which is X, divided by 0.105. Now, this is where you need to do an additional step. And this is why you write out reactions so you see what you're getting. So when you find this X, is that your hydronium ion concentration or your hydroxide ion concentration? That's your hydroxide ion concentration, okay? Because it's acting as a base. So when you get X, that's going to be your hydroxide ion concentration. If you take the negative log of your hydroxide ion concentration, what are you going to get?
POH.
Your POH. Now, and again, this is, you don't have to have this memorized, it's on your sheet, which you're going to have available for the quiz. Your pH plus your POH add up to 14.0. So to get your pH, subtract your POH from 14. Now, this is going to be a basic solution. So when you get done, should your pH be above 7 or below 7? Above 7. So your pH on number 80 should be around 8. Okay? Like that, Gapshot? Okay? So that's about as complicated as they get, is that whole step right there. And again, if you're making comparisons, look at how they're calculated. So if you look at how Ka is calculated, oh, that's your hydronium ion concentration times your anion concentration divided by the concentration of your acid. So the only thing you can do to manipulate this Ka value is look at the concentrations of those hydroniums and anions. If these numbers, because they're multiplied together, are bigger, that means you produce more of the acid. It ionizes more, that means you have a bigger Ka value. If these numbers are exceptionally small, that means you're going to have an exceptionally small Ka value. That's it, okay? Don't stress out. Any questions on the assignment? Yes?
Number 20.
I don't even remember it. I just remember being confused. I was like, where do you,
Okay.
how do you know where to put H?
The only thing that's available is water. So you have H, so on 20A you have H2, C, whatever it is, H7, C6, H7, O5, 1 minus.
Yeah.
And you're told that that's gonna act as a base in water. So what's the only place that it can get a proton?
I know that you take it from water, but where do you put it?
You attach it to this, so you put it as H3, you can just write it as H3, C6, H7, O5, but then, because you're adding basically a proton to it, what happens to the charge? You don't have one, but then you have an OH minus. That's it, that's all you have to do. If it acted as an acid, you would give a hydronium ion, and then you would form H3O plus. If you were told that it acted as an acid, you would decrease it by 1 and make H3O. Okay? Do not make that complicated.
I did.
Don't make it complicated until I tell you to make it complicated. Okay, we're good? Once, twice sold. Get that handed in.
So larger.
I just realized I turned in
I have
last
no
night
idea.
that I had questions on,
Acid
and I just left them unanswered.
What?
For the,
So you
I
want the
mean,
one that
20,
I know?
the high, the, I get acid and base, are those, right, or do I have to open those?
You want me to stop that, Mr. Bergman?
Sorry.
Mr. Bergkamp,
What?
you want me to stop this?